Hello and welcome to CodeSlicing. In this episode, we're going to be finishing off the shield we started in episode 1. So if you missed that, go back and watch it. I mean, you don't have to, of course, but if you want to be brought up to speed, that's probably a good place to do it. We're going to be doing the texturing and the shading in this episode, and it's really quite amazing what a difference that makes. Enough talk, let's do it. Right, so here we are where we left off in part 1, and we've got our shield that needs a little bit of love and attention, and we're going to do that by adding some shading and texturing to this thing. And we're going to start with the texturing. We're going to make it look like it's spun up from an alloy of vibranium and adamantium. And we actually want to make it look like brushed aluminium. And the way that we're going to accomplish that is going to be by using ever-increasing circles. We'll use blend modes, and let's just get to it, and I'll show you what I mean. Let's just constrain the Z stack itself to be the diameter. All right, and then we'll say we're going to clip, and then we'll clip it to a circle. The next thing is that one of the advantages to using a Z stack like this is if we want to solo a layer, we can now just put a white layer in. We'll just say that. And now we can work on our layer without worrying about what's underneath it. So we can see clearly what we're doing. What we're going to make is a shape consisting of 100 circles. And because it looks like brushed aluminium, we're just going to call it brushed overlay. And we're going to put in 100 circles. So for this, all we need to do is iterate over 100 circles, increase the size of the radius for each one, and give it a little bit of randomization. You'll see what I'm talking about in just a second. First thing we need to do is calculate the step between the sizes of these circles. So let's calculate that now. Let step equals 1 over the number of circles as a CG float. And now we've got the steps. We just iterate over the number of circles. And we're actually going to go from 1 to the number of circles because I don't actually want one right at the center. I don't want a dot at the center. All right, so we'll say for index in 1 to the number of circles. And we'll add an ellipse for each one, which is going to have an origin of the center of the original rectangle. And what we want to do is we want to scale the rectangle, which we know is a square, by the step size times the index that we're on. We take the rectangle and we say size scaled. We times that by the step. And we times it by the index as a CG float. Now we've got our rect, we give it an anchor, which is the center. And then back in our view, after the white color, we'll say brushed overlay. And we'll give that a stroke color of gray with a line width of 0.1. Again, that's related back to the diameter of the shield, which we're assuming at this point is 400. And we're going to normalize that at the end. So let's resume that. And if you can see that, it's there, but it doesn't really look the way we want it to look. If we zoom in, we can kind of see a very regular pattern, which is not what we're going for. So what we'll do is add a little bit of randomization. And the way we'll do that is very easy. We're just going to say 0.02 random, like that. And look, immediately we've got our randomization that we're looking for. This is much nicer. This is what we're going for. All right, so let's go back to where we were. Okay, so we're back in the view and we're nearly done with this one, but we want to blur it and set a blend mode on it. So we can do that like this, blur, 0.5. Okay, that's nice. So all of the circles are now blurring together nicely and really giving us a nice variation. And we set the blend mode to multiply. And now if I take off the white, all right, brilliant. There's our brushed aluminium look that we're going for on the shield. We're almost there. Now we need to add the highlights. Okay, this is the shading that's really going to bring this to life. So again, we will set another layer of white. Now for this shading, I'm going to use an angular gradient. And it's not going to be a simple one because I'm going to have to do some calculations along the way. This means that ideally I would be initializing this as a file level constant in the form of what in JavaScript is called an IIFE, or an immediately invoked function expression. Now the Swift equivalent would be the immediately invoked closure expression. So what would that be called? An ICE? But if I defined this as a constant ICE at the top of the file and then try to work on it, every time I made a change, I would have to resume the preview to see what difference it made, because in SwiftUI, one of the limitations of the preview is that if you make changes at the file level or you add methods or variables to your structs, then the preview will pause and it will require you to resume with a little rebuild, and you don't get the immediate live updates that are so nice. A nice little trick that we can use is to dump the entire ICE inside a modifier. Work on it there with the benefits of live updates, and once we're satisfied with what we've created, we can extract it out into a constant. So we're going to create a circle to start with. All right, so there's our fill modifier. We're going to put this ICE right in here, and we're going to say that it is an angular gradient. So how are we going to do this? Well, the process involves creating stops. If you've never dealt with stops when talking about gradients in SwiftUI, what they are essentially definitions of points from 0 to 1. And when we're talking about angular gradients, 0 is the angle at 3 o'clock, and 0.5 would be over to the left at 9 o'clock. A value of 1 brings you all the way around the circle clockwise back to where you started. For each stop, you give it a color and a location in the form of one of these angular fractions. Okay, so the first thing we need are the stops that are going to define these conic highlights. So stops, which is of type stop. We'll just initialize it to an empty array, and then we can return our angular gradient to stop it shouting at us. We give it the stops we've just defined, and we say that the center is the center. That should stop it complaining. And now that it's happy, we can loop through our stops. All right, so for index in 0, 4. Now remember, we want to go from 0, which is over to the right, all the way around clockwise back to 0, and we want 4 quarters, so there are going to be 5 stops in total. Now let's define the highlights first, which are going to be white. So we'll say the stops, we're appending a stop. We're going to say it's color white, and the location of this particular stop in the fraction from 0 to 1 is going to be the offset, which we haven't calculated yet. So let's say that the offset is the index times a quarter as a CG float. Now you won't see anything at this point, even though there are 4 of them, or 5, they're all the same color, so there's nothing for it to actually vary between. We need to give it a dark color to give it that gradient. So this is where we need to talk about the width of the highlights. We want these highlights to be spread out over a certain angular width of the circle in the form of a fraction from 0 to 1. We've got 4 highlights in total, and I want the widths of these things to be just less than a quarter at 0.2. it looks a little better in my opinion. Obviously, this is artistic license. You can do whatever you like. So I'm going to define a half highlight radial width, which is a CG float of 0.1. So 2 of those is 0.2. But for that, we need a color. And that color is going to be half gray. All right, half gray. Now we can put in that stop before the highlight. So we'll say stops, append. We'll initialize that with a color of color dark that we just defined with the location of offset minus the half highlight radial width that we just defined. As you can see, the highlights are not symmetrical, right? And we can fix that by putting in another one below it, but this time saying plus the half highlight radial width. So now we've got this ICE we've been developing with live updates, and we can extract it out into its own constant at the file level to clean up our view. So we can just grab it All right, get rid of that. We'll come back to that in a second. All right, we'll go up here and we'll say private let the conic highlights is equal to, we've got to give it a type here of angular gradient. Now we've got it. Okay, we've got our conic highlights and we just fill it with that. All right, lovely. So if I resume, we should see what we saw before. And we're almost done now. I want to blur this a little bit. So as you can see, the highlights are looking a little bit sharp. All right, so let's give that a blur of 4. Like that. Okay, that's nice. Remove our white layer like that. So we can see exactly what we've got. We can't see anything because I haven't turned the blend mode on. So let's say the blend mode is multiply again. Oh, that's looking much nicer. Now, the only thing I don't like about this is that right in the center, it's looking a bit dark. Okay, I want to brighten the very center of this up a little bit. And I'll do that by adding an overlay of a circle. All right, we're going to fill it with white. We'll give it a frame of 15, so it's only small right in the middle. And a blur of 6. Now, as you can see, that made no difference whatsoever. Watch this. If I turn off the blend mode, you can see that it is there, right? That little circle I added is giving some highlight to the very center. And there is a small bug in SwiftUI when it comes to blend modes and descendant views, because this should work, right? If I add a blend mode to all of that, right, it should work. I should get this highlight in the middle. We can actually fix that by saying that that is a drawing group. See what's just happened? We've now got our highlight in the middle, or at least not a low light. So that's the way to fix that problem if you come across it. And now we're almost there. And all I want to do is rotate those highlights just a little bit. I'm going to say rotate it by 10 degrees. Lovely. Just makes it a little bit less symmetrical and more pleasing to the eye. There are 2 things left. We're going to normalize these values. Let's do that first so we can put it on any size of shield that we like. So let's say, have a little function here called Normalize Value. We'll take in a double, we'll give back a double, they are doubles in all cases, and we'll say the diameter that we've got, or the diameter that's being used for whatever one we're doing, times the value over 400, which is the original one that I've sized everything to. Everything is normalized to 400, so we can get any value out of it by using this function now. Any value for any diameter. So now, instead of a line width of 0.5, normalize value, like that. Let's copy that. We'll do the blur. We're going to normalize that blur. We'll normalize this line width. We'll normalize that blur. And that line width. And that blur. And that blur. And that one. All right, we're normalized. If I resume that, it should look exactly the same. And it does. The last thing I want to do is just make the center of it rotate, just for fun. And we only have to rotate the middle of it. We only have to rotate the star and the star detail. That's very easy to do. We'll set a little variable here. Say rotating. It's not rotating. And when it appears, we'll say that it is. With an animation of linear, with the duration of 20, nice and slow. And repeat forever. Auto reverse is false. And we'll say that the rotating is true. We are rotating. And then we put all this in a group. And we say rotate if rotating 360 degrees. And if we play that, we should see it rotating nicely. So now we can base it on the size of the device. Because we've normalized this, we can say that the diameter is going to be the UI screen, the main size. We'll say it's the min dimension minus 100 to give it a bit of padding. Now we have to resume that because it's a file level constant. All right, look at that. We've got 50 on each side. Actually, let's make that 50. It might look a little bit better. All right, let's try it on a different device. Let's try preview device, iPad. We'll say the 12.9 inch one. It's going to be massive. Let's scale it down. Oh, the simulator's not handling this very well. But we can see that it looks just as good. I'm going to have to pause this because it's really killing the simulator. But there we are. Looks just the same, normalized to that size. Absolutely perfect. All right, so there you are. You've got a shield you can use whenever you like to fight off the bad guys or just flex a bit with your SwiftUI skills. What a difference shading and texturing makes, eh? If you found this useful, then drop a like. If you want to see more of this content, consider subscribing. If you have any comments or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.